All right, so here we're looking at trigonometry fundamentals. We're looking at right triangle trigonometry, SOH-CAH-TOA. So it's all based on this idea that we have a bunch of similar triangles, right? We can scale them up, we can shrink them down, but we know that certain sides have certain ratios, relationships that are locked into place. So again, similar means same shape, but different sizes. So the sine ratio is always the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So whenever I look at a right triangle, my biggest angle is opposite my biggest side. So this is my hypotenuse. Now my opposite and adjacent sides, those are always legs. So from 62, from this reference angle, this is the opposite side. This is the adjacent side, the one that it's touching, that it's connected to. From 28, this degree measure, this is the opposite side. This is the adjacent side. So if I start by looking at sine 62 right here, opposite over hypotenuse, I have opposite over hypotenuse, u to n. Cosine 62, that's the CA, so adjacent to hypotenuse, f to n. Tangent 62, opposite over adjacent, u to f. Switch to the other reference angle, that 28, sine 28, opposite hypotenuse, f to n. Cosine 28, adjacent hypotenuse, u to n. Tangent 28, opposite adjacent, f to u. Okay, one other thing to point out to you is right here you see that cosine 62 equals sine 28 and sine 62 equals cosine 28. They have the same ratio. Well, let me just write out one of those pairs. So sine 62 equals cosine 28. Why do they have the same ratio? Well, from here, my sine ratio, opposite hypotenuse, is the same as when I go to the other complementary angle of 28. When I say cosine, here's my adjacent hypotenuse, same ratio. So we see that sine and cosine are going to produce the same ratio when their reference angles here are complements, when collectively they add to 90 degrees. So let's say that I make up one more option. I should know that sine 10 is equal to cosine 80, right? 10 plus 80 gets us back to 90. So when these angles are complements, when their measures add up to 90. Okay, next looking at a 30-60, or not a 30-60, a 3-4-5, a common triple, right? A side length of 3, 4, and 5. It's the most common Pythagorean triple that we see, right? And again, I could scale this up or I could shrink it down, but we should notice that it is a common Pythagorean triple, and that the side opposite my right angle is always the hypotenuse. It is the biggest side. So here I'm thinking of SOH-CAH-TOA, if it helps to write it out again and write it out again. So if I say tangent B, I'm going to where B is, and I want my TOA. I want my tangent. So from B, I want opposite adjacent, so 4 to 3. Cosine A, so from A, I'm looking at my adjacent hypotenuse, so 4 to 5. Sine A, opposite hypotenuse, 3 to 5. Okay, cosine B, so from B, cosine, so we're looking at the adjacent hypotenuse, so 3 to 5. Sine B, we're looking at the opposite hypotenuse, so 4 to 5. Okay, tangent A, so back to A, opposite adjacent, 3 to 4. All right, for these last two problems, you're going to need to have a scientific calculator or a graphing calculator that has trig functions. So here I'm saying, can you use ratios to write an equation and solve for x, round to the nearest 10,000? So I want 4 decimal spots. So again, a reminder of SOH-CAH-TOA. All right, so from my reference angle of 27 degrees, I have an opposite side and I have a hypotenuse. So that means I'm going to use sine. So I can say that sine 27 is equal to x over 25. Okay, I like to build a proportion, so visualize sine 27 over 1, and now cross multiply. So x equals 25 times sine 27. All right, so 25 times sine 27 ends up as 11.3498, about. Okay, next one here. From this reference angle, I have an adjacent and a hypotenuse. So I'm going to use cosine. So I know that cosine 34 equals 19 over x. Again, visualize it as a proportion, a ratio equal to a ratio. Cross multiply. So x times cosine 34 equals 19. Divide out cosine 34. So now I have 19 divided by cosine 34. So x is about 22.9181. All right, so both of those we were solving for a missing side. Now we want a missing angle. So use ratios to write an equation and solve for theta, round to the nearest 10,000. So CAH-TOA, write it off to the side again, just to really drill it back into memory. So from this angle, theta, I have an opposite and an adjacent. So I'm using tangent. I know that tangent theta produces the ratio of 10 to 11. And if I want to solve for theta, I can use the inverse of tangent with that ratio to produce that angle measure. So here I'm going to hit second tangent. That reads as inverse of tangent. And then plug in the ratio, and then it pumps out the angle measure. So 42.2737. degrees. Okay, last one. So from theta, I have an opposite, I have a hypotenuse, so I must be using sine. So I know that sine theta gets me a 12 to 17 ratio. So now I can use the inverse of sine with that ratio to produce my angle measure. So I do second sine, 12 over 17 gets me theta. So 44.9009 degrees. All right, have a good day.